So I'm going to see how working with two smart files goes today. My computer might just end up blowing up. I hope that will be done. So I need to slide this down here really quick for our classmates that are ill and at home following along with us. Homework's 99, 103. 99, 103. Where I worked for 99 or 95, 95, 7, and then they switched to 102. No, we were really weird numbers in college. Our radio station was like just one. All right, WNCF plays the same music all day long. So, anyone want to read our start paragraph, or are you just gonna have to listen to me? All right, so hopefully you do know it. I know it says you may not know it, but you think mathematically every single day, and not just because I make you do it. So you think mathematically when you decide whether or not you can purchase something, right? If you can afford it, afford means have enough money. Right? When you read a graph on a website, hint, hint, nudge, nudge, Foundations this morning, looking at graphs. You think mathematically when you double a recipe, which sometimes works and sometimes doesn't. Who's tried to double a recipe before? Okay. How much you'll get to take somebody based on how far you have to go, like how long it's going to take if you're driving to grandma's house or anywhere like that. So we're going to start to get really good. Why did you change layers? We're going to start to get really good at comparing quantities and talking about relationship between values. So I want you guys to look at 593 and think about how to compare the two situations, how you would write them, how we can represent this with math, symbols or numbers or different things like that. So check out 593. Maria has 15 marbles. And please make sure your notes have a header. Some of you did not turn in your math journals. That's going to go into math today as a missing. So be aware of that. Get your math journal in as soon as you can. We'll leave this bin. If anyone still needs to turn in their math journals, say do so there. So get something down on your paper. You can draw a picture to represent it if you want to write it mathematically. You can try to write it mathematically. If you can solve how many marbles Dahlia has, try that. Situation 1 and 2 make be different, right? Or Maria has 15. So you can draw a picture. For those of you that don't like drawing, you don't have to draw a picture. You can modify those instructions. So drawing a picture could help. Do you want to read situation 1 with good emphasis on what you think is important? I'll maybe go back to language. Yeah, Marvin? So who has more marbles there? I think Dahlia is her name. This is 10 less than Dahlia. So if you're, sorry, I shouldn't be working on there. You're working up here. If you're reading this and you see this is 10 less than Dahlia, how do we write something is less than, we can use the symbols, right? But that's not really what we're trying to do here, right? We know Maria has 15 marbles. So just to start out with, guys, could I at least write down, because I see a lot of blank papers as I walk around, could I at least write, like, Maria has 15, just to get something on my paper? And then it tells me Maria has 10 less than Dahlia. How can I show 10 less than what Dahlia has? Oh. That doesn't really show 10 less than. You're kind of like solving. You're like moving ahead to the next step. I want to say that Maria, or Myra, I guess we could say, has 10 less marbles than what Dahlia has. How do I say, like, I have 10 less than you? What if I start with comparing? What are those hands? Liam? Okay, so we could say Dahlia has 10 more than Myra, right? Because but that doesn't exactly show what they're asking us to. We want to say this is 10 less than Dahlia. What do we do to make something less than it is now? What operation? Yeah, minus, subtraction, right? So we want to say that Maria actually has Dahlia's amount minus 10. So please get that equation down. Maria's is 10 less than Dahlia. Now, since we know M is 15, and I used M here, we can really say 15 equals D take away 10. Right? Dahlia's amount of marbles take away 10 is how many Myra had. Myra had 15. So now I go back to Ella. Ella said, well, the way that we can solve this is if I know you've got 10 less, then I've got 10 more than you. So, Ella, what did you tell me to do again? Yeah, if we look right, please make sure you have this equation on your paper. Then we're going to, and I would love if you change colors. So if you want to grab a colored pencil real quick up there, over here, we're going to do something to both sides. We've talked about this a little bit, but now as we get deeper into equations, to get D by itself, we're going to add 10 on both sides. How many marbles does that mean Dahlia has? How many? 25, right? For situation 1. Situation 2 still starts the same. Maria's got 15 marbles. Is there anything different about situation 2 than in situation 1? Patrick?
And whenever it's talking about Dahlia has less, it says it's worded differently.
Ooh, it's worded differently. Okay, how so? What do you mean?
To where it's like, this says that Dahlia has 10 less than Maria.
Ooh, Dahlia now has 10 less. So who's got more marbles?
Maria.
Yeah, Myra, however we're going to pronounce. So Myra's got more marbles. Ooh, and Myra's got 15. How could we express this? Dahlia has 10 less than Myra, right? Dahlia has 10 less than Myra. What do you think, Lee? Yeah, so we could first, I'm going to actually add a step before that. We could say Dahlia has the amount that Myra has, but take away 10, right? If I want to just say that Dahlia has 10 less than Myra, Dahlia has 10 less than Myra. Then, because I know that Myra has 15, so please get those equations down. And then that solves easily. We don't actually have to do anything special. How many marbles does Dahlia have here? 5. Now be careful. Weren't those phrases really close to each other? This is 10 less than Dahlia. Dahlia has 10 less than Myra. Very, very close. Totally different answers. Right? They mean two totally different things. So we have to be very careful as we get into converting verbal expressions into numerical expressions or equations. Equations just takes one expression equals another. Questions on this, how we did it? All right, check out 94 on your phone. Read through it with your partner. Look at Ellie and her dollhouse and see if we can help her. This one, because it's easy to draw a picture, I would like you to draw a picture, please. Well, this is weird. One board is 7 inches longer than the total length of the three of the short boards. So I'm going to give you a tiny bit of start and then have you guys work on your own. If it wants us to draw a picture of long and short boards, maybe we have long and short. But you want to make your drawing represent what they're telling us. So, have a shot, or take a shot. Try it somehow. One long board is 7 inches longer than the total length of 3 short boards. So how do we draw that as a picture? Can anyone mess with my drawing to make it show what they want us to? Alex, okay, is there anything else we need to add in there or anything else we need to show? Do you know, or do you want me to pass it to somebody else? Nice. Okay, perfect. Now, Grant, as we move on, it asks us, what are some possible lengths of her boards? Did you think through that question? Okay. Were you raising your hand about C? So, Alex's modification of my picture is absolutely correct. Please make sure that in your notes you've shown a long board, not a long board, a skateboard, a long board, and then 3 short boards beneath it, all the same length, 7 extra inches, and that makes up the long board. Look at part C. Try to solve that with your partner. I'm going to give you a few minutes to work on this. If you get done with this, move on to the next problem. We should all have a textbook in front of us, at least one in our group. Matt, what's part C tell us? What's the important stuff in part C? The longboard is 50 inches. So this, we could label, can't use green. So everybody on their drawing should have labeled that 50. Work through with your drawing to figure out how long the 3 short boards should be. Take a moment to do that. Sweet. If you think you're done, then you can move on to the next question. Allie, do you have an idea of what I could do to try to figure out the length of my 3 short boards? Ooh. So you're actually a step ahead of me. First thing I need to do, which you jumped over this step, is if I cut right here and I take that off my longboard. Now, don't cut your longboard. You're going to mess up your plans. But if I kind of think this through, how much do I take off? 7. So if I take 7 off my 50, that leaves me with this being 43. And then Allie said, well, if that's 3 short boards, divide by 3. Right, now 43 divided by 3
is 14.3 repeating.
14 point, now, 14.3 repeating. Is that the best way to represent inches? What's another way we could write our number? Yeah. Ooh, no, because that's actually not right. 0.3 repeating is not 3/10. Yeah, but, so don't write this yet. We could do this. Sorry, that's a period. But that's still not quite right in inches. You're really going to look on your ruler for 14.3. We don't talk about inches like that.
14 and 1/3?
A third. If you get repeating decimals, unless your question specifically says give a decimal answer, repeating decimals are not very nice. We would prefer to use fractions when possible. Does what we did make sense to you? Yes? No? Now, we're going to show you the algebra behind what we did. So what we just did was kind of geometric, right? We drew shapes, we made a picture, we looked through how we can visually get to where we're going. What did we get told? What's the first thing they told us? Alex?
The longboard is 50 inches.
So that's one thing we found out eventually. So that's info I'm going to write down. The longboard's 50 inches. What else did we know?
That there was 7 inches with no, 7 inches where a small board cannot reach.
What do you mean?
Like the small board, if they would only cover 3 small boards, only covered up a certain amount.
Ah, so the other thing we knew was the longboard was equal to 3 small boards and 7 extra inches, right? Please get that down on your paper. Both of these would be beneficial. We are now going to substitute. Just like Mrs. Goring has a substitute here today. Somebody filling in for you. If I know what L is, I can plug it in where I see an L. If I know L is 50, which we didn't know at first, quote unquote, we can then actually just say, well, 3s plus 7 equals 50. So please then set your equation instead of being equal to L. You can just move it over here, and now this L equals doesn't matter. We don't care if that's there anymore. We're going to work with this. Cool? Everybody good? Algebraically, what would be my first step? We did it visually. Allie, what did you do? Well, actually, it wasn't what you did. I had to do this because Allie skipped a step. What did I do first over on previously? We took something off. We subtracted, thank you, 7. We took 7 inches off the board, quote unquote. Then Allie had gotten to a point where she found out that 3 small boards was equal to 43. Allie, what'd you do then? Yeah. Then we divide by 3, divide by 3. Was it 13? 14.
14.
Any questions? So, we're actually working with multiple variables. When we started, all we knew was this, right? Long board is 3 short boards and 7 extra inches. With only that information, part B asked you what could be the lengths of your board. We don't know. We didn't know enough information when we started. Then they tell us one more piece, we fill in, and we're able to solve it. Any questions? Try 95 on your own. You can represent it however you want. If you can do it mathematically, awesome. Otherwise, you can draw a picture. Try 95. I would only look at one of them at a time. So if you start with situation A, don't even look at situation B. Just do problem A. Then do problem B. I would use a capital A if you want to be like problem A. Sometimes you're just writing down stuff because you want to get it down mathematically. So first thing to tell you, Diana has $16. You could write that mathematically. What do you think, Pyro? J-A-I-R-O. J-A-I-R-O. Pyro? Otherwise it's like Jario. I actually yesterday feedback I gave was the book should have phonetic pronunciations. For the first time we see these names. Okay. You're talking about problem B?
No,
Yeah, problem B. Yes, but we could actually represent it differently to begin with. So the second part of that, when it says she has twice as much money as Jar, you could mathematically write Diana has, right? What does has mean mathematically? Like equals, right? Like an equal sign. Twice as much as Hiro, and then you could get to here. Like that's fine, but if we want to be formal, we would write something else before that. Aubrey, in problem A, we're only going to look at problem A. What's the first thing you wrote down? Thank you very much. Some people think that like that's unimportant, and it's just there's nothing to solve. That's really important to write down, guys. Getting that on your paper is really important so that you have that easy to work with and plug in. And then what did you write down next? Do you know? Ooh, I love it. I'm actually going to take a step between. If it tells me that Hiro has twice as much money as Diana, that mathematically can be written in J equals 2 times D. Now we know D is 16, so then I can plug in, say 2 times 16, and how much money does Hiro have? Hiro has $32. Now, in problem B, Liam, what'd you do first there?
Well, D equals 16, and Hiro has half of that, and so 16 divided by 2, and that's 8.
Now wait, is that actually what it tells you is Hiro has half?
She has twice as much money as Hyro.
Ah, so this statement right here, this is what I was talking to Patrick about. So give me your eyes for a second. That statement converts to the mathematical equation. Okay, so start with the beginning. She, who is she? What did we represent she with? So what are we using? D, except I don't want highlighter. D has, mathematically is an equals. What does it then tell me? Eleanor? 2 times what? Problem B, right? Make sure you're looking at problem B. Chill for a second. Give that Eleanor. She has twice as much as. So D is 2J, right? Be careful because it's not 2 times 16. Not in this situation. Sorry, is that a hand? Yeah, what's up? Hold on, be careful. And this is why we got to think about what we need to do next. So we know we have 2 things written here, right? D is 16 and D is something else. Delaney? Yes, but what I think about before I get there is substitution. If I know what D is and then I reference D here, just plug it in. So if we now can say 16 is equal to 2 times J, what is 16 equal to? Double of something. What is that something? Gotta be 8. Because we then, on both sides, could divide by that 2. We want to show it mathematically. Hyro has $8 here. Questions on that? Be really careful. How they set up the phrasing completely flips the situation of whether Hyro has double of what Diana or whether Hyro actually has half of Diana. But up here, a couple of you guys said, it tells me Hyro has half. Kind of. It tells you Diana has twice as much, which means Hyro has half. But we want to actually write that out mathematically. Questions? Okay. Moving on to 96. Sorry, guys. You're going to end up hungry. Check out 96 with your partner. I'm sorry, that's not my fault. See if you can figure out the unknown quantities in these situations. Is that a hand? Can it be a hand? Okay, I'm using cards anyway.
No.
So, could you tell me what, when you look at A, how that kind of, reads or how you interpret that? Okay, there's 10 inches missing from the top part in order to be the same as the bottom. If you were to describe, that compared to that, how could you, reference them? Think back to the last problem. Or 2 problems ago when we were working with the boards. Do these look to be the same? Do these look to be the same? Is one smaller, one bigger? So could we just call these, smalls and these, larges? Something like that? just to give some variables, some sort of name. Is this kind of like, do you want some help on this? Do you want to tag somebody in? You know, Aubrey or Alex? Ooh, looks like is dangerous. I agree, but looks like can't be trusted. We gotta do math to figure it out. Do you have any other idea? Aubrey, do you have another idea?
I was gonna say 2/3 because I like visualized in my head if I put the two smaller cubes instead of the larger cube.
That might be true. Like, I'm not saying this isn't true, but we have to go to prove that somehow. Alex?
2 short boards is equal to 2 long boards.
Close.
Minus 10.
Okay, so I like it, but let's phrase it a tiny bit differently.
Good morning.
Good morning.
Thanks for the interruption. Thank you.
What? Okay.
Good morning. Eleanor? Yeah.
2 long boards equal 2 short boards plus 10.
2 short boards plus 10 equals 2 long boards. Please get that in your notes if you did not already figure that out on your own. These are the same length, right? The reference points that they show you from here to here, same length. 2 short chunks plus the 10 equals the 2 long chunks. Do we have enough information to move forward and solve? What do you want to do, Grant?
So my thought, it says assume the lengths that appear to you are equal.
Yeah, so like short is equal to short, long is equal to long. Like that these are the same and those are the same.
But I concluded that the small pieces are equal to 2.5.
How?
Because I assumed that there are 3 smallest together. And then
Okay.
10 divided by 4, because those will be the small pieces left.
So you said you assumed? Do you know this? No. Now, if you guess check, and you say, well, what if, let's play out like a hypothesis situation, right? What if I call this 2.5 and 2.5 and 2.5? That makes this, how much? 2.5 times 3?
7.5.
Yeah, 7.5. What is 10 take away 2.5? 7.5. But we kind of like, did we know that to get there? That's the question. So actually, you guys are right with the 2/3 and the 1/3 left and one more fitting in. Totally right. But we don't know that for sure with the info they gave us. Can I move, like let's imagine if I take this and I move it over here, or move it all the way to the end, let's even say. And let's put the 10 inches in between them, right? So what if I make my 10 inches from here to here? What if I cut the whole thing in half to look at what 1 long would equal? So I moved this piece over to here. I moved my 10 inches to the middle, and then I cut the whole thing in half. Alex?
So now equals 10 inches plus 1 short board.
Close.
So 5.
5 inches plus 1 short board. Because, on your paper, please show, if I cut the entire left side in half, and cut the entire right side, I cut the whole thing in half. Because what I have is 2 longs. I want to talk about 1 long. Now, at this point, we could guess and check and hopefully get somewhere that works, but we don't actually have enough information to solve unless we do some guess, check, and play with it. We could also get to a point where we get short is equal to long minus 5. Yeah, we can guess check our way there, and it works out nice here. But we'd like to fill in one of those variables. We'd like to know. Try C. We're going to skip B. B, if you have something down here, we'd probably have 2 and 4 and 5 if you counted your quantities. We've got like a triangle made with those legs. We could say that 2 and 4 is a longer distance than 5 because this is the easiest way to get from point to point. We'll look at C. If you haven't done C yet, take a moment with C. By the way, there's 5 in each of these stacks, and there's 2 right there. Is that referencing back to table of contents or what?
Yeah.
Okay, so when I write Q, see if that means table of contents. Emma, how can I represent my left box up here?
There's 3 boxes.
So 3 boxes plus 2. Okay, do you know how to represent the right side?
1 box.
1 box
Plus 20 cookies.
plus 20. Please make sure we have that on our notes. Now I want to start kind of working down and figure out how many cookies are in each box. I want to start to remove things from this situation and make life easier. I kind of want to use cards, but now I have hands and not make things hard. Ella, I actually skipped your card, so I'll go to you. Well, I'd already talked to you today. So Ella, what do you want me to do?
So there's 4 sets of patterns, there's 20, and on the other box with the cookie box, cookie boxes each, there's 2 that are the same.
Yeah.
What I did, in the other is we took 2 away from the 20 and we got 18.
Ah, so if I take these 2 cookies away from this situation, I got to take 2 cookies over here away from this situation. So please show in your notes. Guys, you got to show this work between steps. Otherwise, it will not be mastered. Like if you skip steps, it will not be mastered. You have to show what you're doing. So we take 2 away from both sides, and we end up with now my left side is only 3 boxes. And what's my right side equal? What's left over there, Marvin? A box and 18 extra cookies. Now, is there anything common that you could remove from both sides? Mr. Kirk?
You could remove, you could split the 18 cookies in half.
Are there cookies out of the box over here?
No.
Okay. So there are cookies out of the box over here, but no cookies out of the box here. Is there boxes or a box over here?
Yes.
Are there boxes or a box over here? Ooh, so that's what we actually have on both sides. An LP.
Take away the box right there.
By the way, how many boxes is B?
1.
How many grants is Grant? Do I need to say 1 Grant when I talk to him? Do I have to say 1B? Can I say 1B? So if you want, if it helps you, put a 1 in front of the B to remind yourself there's 1. But then we're going to take that 1B away. So sorry, 1 box. I'm going to eat you. So now what do I have? Alex? 2 boxes is 18 cookies. What can I do now? Kate, split that up. If 2 boxes is 18 cookies, then 1 box must contain... Wow, the Girl Scouts are really cutting back. Those better be tag-alongs. Let me tell you what. Ew! Chocolate peanut butter?
Oh, that's what that's the one.
I'm not talking about a Samoa.
Yeah, I like the so good.
See how passionate people. Now, what if I bring a Boy Scout popcorn? I bet nobody's very passionate about like ultimate butter all the way.
I don't like popcorn.
All right, we almost made it through everything. I forget what else is left. Hold on, we got like a minute left. Let's talk real quick. So, hey, let's talk real quick. We're gonna talk true false. I got like a minute left. True false on these statements. According to this graph, is it true or is it false? Rich is 1 foot shorter than Kristen. True or false? Give me a thumbs up, thumbs down. Rich is a foot shorter than Kristen. Rich? Yeah, true. Boom. Ariel is twice as tall as Rich. Ariel is twice as tall as Rich. What would we need to do to that statement to make it true? Flip it around. Rich is twice as tall as Ariel. That would then be true. Kristen is 1 foot taller than Ariel. That's not what it says, right? Kristen is 1 foot taller than twice Ariel's height. Ah, that one's actually true. And the sum of the 3 children's height is 10. No. Alright, thank you guys. Have a wonderful day. Please do your homework. It is due on Friday.